So hi everybody, I hope all of you are doing great. In today's lecture, we're going to see a very important and a very classical dynamic programming question which is called Russian doll envelopes. This is a follow-up problem of longest decreasing subsequence which you have already seen before. And if you do not know what is a longest decreasing subsequence, what is dynamic programming, I've provided a link to I button here itself. And you can of course check that problem out first before you get right into this problem. So let us get right into the problem statement and see what the problem is saying. You are given a 2D array of integers envelopes where envelopes of I is equal to width of I and height of I represents the width and the height of an envelope. Okay. So they are giving us an envelope, right? So envelope you can of course imagine of, rectangular shape, right? And for every envelope, they are giving us n envelopes you can imagine. And every envelope, like they are representing, they are giving us the width and the height of that envelope. One envelope can fit into another if and only if both the width and height of one envelope are greater than the other envelope's width and height. We'll of course analyze this on board. Return the maximum number of envelopes you can Russian doll, right? Russian doll is of course when I started the video, you can see a lot of Russian dolls were there. Like those dolls were called Russian dolls, and you can put those dolls each inside each other, right? And this is the same thing we want to do with these envelopes. I want to put envelopes inside one another, right? And you cannot of course rotate an envelope. The envelopes are given, like width and height are fixed. You cannot rotate the envelope to change the dimensions, and you have to tell me the maximum number of envelopes you can fit inside one another, right? So let us analyze this on board more clearly and see what is the problem statement saying actually. So let us take this test case for instance. For example, these are the envelopes which are given to us. This is the 0th envelope having dimensions 5 cross 5, 7 cross 6, 5 cross 6 and so on, right? So of course they are giving us the dimensions in terms of width comma height. So for this particular envelope, you can see the input would be 6 and 7. 6 is to 7, right? 6 cross 5. So something like this they are giving it to us, and we have to try to put these envelopes inside each other. Now, what do I mean by I want to put envelopes inside each other? I cannot put envelopes like this. No, they do not mean this in the question, right? This is of course a misconception. I do not want to put envelopes like this. In one envelope I will only put a single envelope, right? What do I mean by that? I'll of course tell you what's the answer for this test case. Let's analyze. So for example, I'll take this envelope for instance, right? And for this particular envelope, let's say I'll select let's say I'll select this envelope to go inside this envelope. This is of course fitting. Yes, this is definitely fitting. For example, now what do I want? Let's say let's say we put this envelope inside this one, right? This would go inside just fine. So I am putting one envelope inside another envelope. I'm not putting two envelopes inside a single envelope. So 7 is having 6, 6 is having 5 inside it. Let's say 5, let's say we put this envelope inside this 5 one, and let's say I'll put this envelope inside this 4 one. So you can see how many envelopes I have, put inside one another. So 1, 2, 3, 4 and 5. So 5 is the answer for this particular test case, right? That we can Russian doll 5 envelopes, right? What is a Russian doll? You can of course see, right? These are these like dolls you might have seen somewhere. You can put these dolls inside one another, right? Doll inside doll inside doll inside doll. This becomes like this makes a Russian doll, right? So this is a Russian doll, and Russian dolling an envelope is making just to put envelopes inside one another, right? And if you just tell me the maximum count of envelopes you can of course put inside one another. I can of course, inside this I can of course choose this envelope. I can definitely do that, right? I can directly put this envelope, but now I cannot put any envelope inside this 1 comma 3 envelope because 1 comma 3 will not be able to hold any other envelope. And when can any envelope hold some other envelope? This is given in the question. So if for example we are having two envelopes, let's say H1 W1, this is the first envelope, and let's say H2 and W2 is the second envelope. I can put H1 inside H2 only if height of H1 is strictly less than H2's height, like second envelope's height, and width of the first envelope is also smaller than the second envelope. They both have to be strictly smaller, right? And this might give you a hint to the previous question we solved. Do you remember in the last question we solved the problem of building bridges? In that problem we talked about north bridge should be less than the north bridge of second bridge, and you can say south of the first bridge should be smaller than the south of second bridge. So it is pretty similar. You can see a pattern of problems is getting observed, that this kind of behavior we want to achieve and to maximize our selection, right? So let us see what we can do, and of course we will be relating this to the previous problem itself, because this is of course a series which is going on, right? But don't worry, if you are directly watching this video also, I'll ensure that I keep it very concise. And if you can watch, you can of course watch the previous videos which is involving longest degree in subsequence. We have discussed 3 approaches of how to do longest degree in subsequence. We have discussed many follow problems as well after discussing longest degree in subsequence itself. So you can definitely check out the previous videos as well. In this video, let's look at the approach for this problem and then move forward. Now, as you can see here, what I have done is that I have sorted all these envelopes on the basis of their widths. You can see. So on the basis of widths, I have sorted all of these envelopes, right? I have successfully sorted them on the basis of their widths, right? And of course, it might seem that, we have actually kind of solved the problem, but you can see if I select an envelope from here, and if I select an envelope from here, can I say this envelope, the second envelope I have selected, will always be having the width greater than the previous one, right? Definitely this is ensured in some cases, for example 2 to 6, but if you look at this case 6,6, like they are having equal, you can say, widths. I cannot tolerate equal as well. I want them to be strictly smaller, right? Okay. So let us first try to relate this to longest degree subsequence and how we can solve this problem. Basically, I want you can say W1 should be smaller than W2, and I want L1 should be smaller than L2, or you can say H1 should be smaller than H2, right? Width of first should be strictly smaller than the second one which I'm selecting. Width height of first should be strictly smaller than the height of second one I'm selecting. Now, if I want to, make this kind of behavior, I want to select the envelopes in such a way that I am not only selecting the envelopes where the previous envelope's width was smaller, I also want to ensure the previous envelope's height was also strictly smaller. So what I have done here is I have sorted all these envelopes on the basis of their, you can say, widths, correct? Okay. So let's look at this problem in a more efficient way. So what I want is, now on the basis of width, they are sorted. Width case is kind of handled. I'm not saying it's completely handled, but I'm saying it's kind of handled, right? Because previous, you can say, envelopes width will be of course be smaller than the next envelope set. In some cases it's going not, but let's analyze those cases earlier. For example, 6 is equal to 6. This is not happening because 6 is equal to 6. That then how are we managing to be increasing order? Don't worry. I want to now manage in basis of height. So can you see, on the basis of height, if I find out the longest decreasing subsequence, I'll successfully able to decide what envelopes goes inside another. For example, this 3 can come before 3 in an increasing subsequence, right? Increasing subsequence, the definition is, of course, we have discussed in the previous video itself. 3 can go inside 4. 3 can go inside 4. And this whole envelope can go inside this whole envelope, because not only 3 is smaller than 4, but also the height, you can say the width of this envelope is smaller than this envelope. Okay. 4 of course is smaller than 5. Is of course an increasing subsequence which we are trying to form only on heights, correct? So of course, because we have handled this case of heights, we can definitely say that this case will also be handled of, you can say, widths, but it's partially handled. And again I'm repeating, don't worry, we'll move forward and see what is going wrong in this approach. So this 6, I'll of course, I cannot select this 5 because I want the height of next envelope to be strictly greater than the previous envelope's height. Okay. Let's select this 6 envelope. This envelope with having 7. Okay, I'll select this 7 envelope. Of course, 5,5 can go inside 6,7, right? Definitely, both of the dimensions are strictly smaller. Now the problem arises. Can you see, if I try to find the longest ring subsequence only on the heights, this 8 will be selected. But can this envelope which is having 8 come inside this envelope of 7? Right? No, this envelope cannot be enclosed in this envelope because their widths are same. So I want to handle this case where widths are same. How can I prevent this longest subsequence, this increasing subsequence, to be formed in a same, you can say, width? How can I prevent this? What will I do? I will of course sort all these, you can say, envelopes on the basis of their widths in increasing order. When the widths are equal, you can see in this case the widths are equal, I'll sort these envelopes only in decreasing order on the basis of their heights. So this 8 will come here, this 5 will come here. On the basis of heights, I've sorted these envelopes in decreasing order. Now let's see what happens here. So 3 I'll select, okay, 4 I'll select, 5 I'll select. Next increasing subsequence will definitely be 8. 8 is greater than 5, right? And of course, this envelope will be coming inside this envelope. Now can you see? Since all the envelopes which are having the same height, I've sorted them in decreasing order on the basis of their height, right? All the envelopes which are having the same weight, I've sorted them on the basis of descending order according to their heights. None of these will be selected in the increasing subsequence because 8 cannot come before 7 in an increasing subsequence. 8 cannot come before 5 in an increasing subsequence. So in a way, I have ignored all these people, right? And I've successfully, of course, considered these answers itself, right? So after sorting them on the basis of like of decreasing order on their heights, right? I have prevented the case where increasing subsequence is getting formed in the people who are having same bits, correct? You can see these are having same bits, and 8 will of course not be looking at these persons. Now it will directly look at the next person which is having 9, right? And I hope it is clear to everybody that what we are trying to solve in this problem, and I hope kind of the solution is clear. Again, if you are not able to develop the insight for this problem, you can definitely look at first longest increasing subsequence video which we have discussed, how to calculate a longest increasing subsequence. Then I would advise you to look at building bridges question which we have already discussed, and this problem is kind of similar, you can say, to building bridges itself. But in the building bridges problem, you can see one difference is there. There you can see all the north banks were unique, right? Here in a way I can say one of the parameters, these are the two parameters which I want to handle. One of the parameter, or you can say both of the parameters can repeat themselves. So this case we are handling in this particular problem. The only difference between building bridges and this problem is that you can see that 6 can come multiple times, unlike the previous problem, right? In north bank 6 will only be coming one time, in south bank 6 will only be coming a single time. Every number will be coming uniquely in that particular problem. Here numbers are repeating as well. So what is the overall solution for this problem? I'll be sorting. First step is to sort on the basis of width, right? Sort on the basis of width in ascending order, and if widths are equal, if w1 is equal to w2, then sort on basis on descending order, on the basis of descending order of heights. And then to find the maximum count to like I can enclose the envelopes in one another to of course get the answer itself, I will calculate the second step. I'll calculate the LIS on the basis of heights. HEIGHTS. I hope this is clear that what is the actual solution for this problem. Let us look at how we are going to solve this problem itself, and let us directly go to the board itself and let's bind up this problem. So we are here in the code itself, and first step I want to do, this envelopes array is given to me, and what do I want to do is I want to sort this array. So I'll write arrays dot sort, right? And I'll pass envelopes here, envelopes. I'll of course provide a lambda function a comma b, right? And I'll pass this array. If the lambda functions are not clear to you, you can of course tell me in the comment section and I can make a separate video on these lambda functions. The syntax is pretty basic. I provide a comma b here, right? Both the data types of a comma b will be of type integer array. This is a 2D array which is having multiple 1D arrays. A and b will be 1D arrays, okay? So A and B are selected. Now the direct formula I told you to sort, right? If I want to sort return, right, we have to write a Java code here itself. So if I want to sort this on the basis of ascending order on the basis of widths, right? So you can see, I can say, return A of 0 minus B of 0. This will sort this envelopes array in ascending order on the basis of their widths. And if two envelopes width is equal to each other, B of 0, I'll return B of 1 minus A of 1. This will sort, this is sorting equal width envelopes in descending order. This is sorting envelopes in ascending order, correct, on the basis of their height, right, on the basis of their on the basis of their width. This is on the basis of their width, and this is on the basis of their height. Okay, so I hope this is clear that what is this function is doing. Let us write the lis code and complete this problem itself. Now, to write the lis code itself, I'll be using the n-log-n approach we discussed in the optimized lis solution video, right? So what we're going to do, I'll of course take a preset of integer. Yes is equal to new preset, right? What I'm going to do next is, of course, I'll form a loop in integer I is equal to 0, I less than envelopes dot length. Let me copy this itself and just paste this here directly, dot length, and I'll do I plus plus, right? So integer height of this particular envelope is envelopes of I of 1. Like, this is the height of this envelope, and on the basis of height, I'm like doing LIS for this, like longest single subsequence. I'm calculating on the basis of height itself. Now let us imagine like what we are going to do here. So heights I've actually calculated. I'll of course find integer ceiling. We can say ceil is equal to ts dot ceiling. This is the inbuilt function. I'll provide h here, correct? So I've calculated the ceiling. If ceil is not equal to null, if it's not, if you are able to find the ceil of this particular number, this particular height, I'll have to do ts dot remove ceil. Okay. And of course, after removing this ceil from here, I'll of course do tset dot, you can say, add h itself, right? This height I want to add. In the end, I'll just return tset dot size, and this will just give me the longest sequence subsequence on the basis of height itself. Let us accept this. Let's try to submit this problem itself. Yes, it is getting passed, and yeah. So this is the solution for this problem of Russian doll envelopes. If you're enjoying the content, please support the channel itself. The next target I am taking is of course for the 500 subscribers itself, and for that I'm going to need your support only, right? I hope you're enjoying the content. Please share with your friends. Please share this on LinkedIn. Please share this on whatever platform you can. Definitely any help is appreciated. Tell me in the comment section if you want to know more about lambda functions. Tell me in the comment section if you want to have some improvements in the video. Of course, like, all the feedbacks are taken care of, and of course I read all the comments by myself. So I hope you enjoyed the lecture. Thanks a lot everybody for tuning in today's video. We are going to of course follow up more DP problems in the next videos itself. Until the next video talks.